All right. So 3 months ago, I was sitting in the back of Testing Talks Sydney, and I was watching Sandeep Kumar talking about enabling continuous delivery with scalable automation and observability. And it was amazing. It was a beautiful case study into what Gumtree were doing at the time as they tackled some of their really most common problems in testing. And he covered things like slow development and release cycles and bottlenecks and unreliable releases. And of course, unhappy engineers losing confidence in their tests. And he spoke about the lengths that they were going, that they'd gone to measure and improve their test suites. They had Prometheus set up, they had Grafana dashboards, they were measuring everything, and it made complete sense to me. It was like a love poem, essentially, to the last 20 years of my career. That was it. It was a standing ovation, at least in my head. I was like, this is great. And he got to Q&A. And then someone from the audience asked, why? Why do I need this time series data? Why should I care? I've got my report at the end. I can see what's failed. I don't need any of this junk. And I was screaming in my mind. I was like, what's not to get? It's clear every company should be doing this. Every company should be measuring this information. And I was like, what am I going to do about this? So I went to the Testing Talks website, and I went become a speaker. And I filled in a description, put in my profile deets, and then I was like, topic. I need a topic. All right. 10,000 builds. And I went back through all of the teams that I'd worked with over the last couple of years. I thought, what is the peak number of builds people are doing these days? And I went through the data and I found some teams doing 10,000 builds per hour. And I was like, what? That's a lot. I won't put per hour. Let's go with like the P75 here. And I dropped down 10,000 builds per day. And so this is a journey to 10,000 builds per day, and why and how they do it. My name is James Hill. I am a product and engineering leader at BuildKite, and my job is to help teams ship as fast as they possibly can without compromise, to be able to deliver, essentially, at speed. But before we get to that, who are these teams doing 10,000 builds a day, and what's up with that? Right, so if you open up your iPhone right now and you look at some of the apps that are installed on there, you will see apps there that were built, tested, and deployed using BuildKite. If you've ever ordered a cheeky burrito at midnight and had some stranger come to your door and deliver it, that app was built, tested, and deployed with BuildKite. If you've ever stayed in a stranger's home, yep, you probably used an app that was built, tested, and deployed with BuildKite. If you've ever swiped right to find some love, you have also used an app that was built, tested, and deployed with BuildKite. So why do these teams care about moving fast? Why are they shipping so frequently? So I'm going to go back and indulge a little bit of my nostalgia here. I go back 23 years when I was at university. I was studying computer science, and this was one of the first assignments I got. And the first thing I noticed was its due date. It was before midnight. Before midnight on the 28th of March, 2002. And I thought, wow, who's collecting assignments at midnight? This must be automated. And sure enough, it was. It was automated. You would run give, would be the command. You'd give some details and the file that you came up with. But you could submit it as many times as you liked. You could submit it 10 times, 100 times, 1,000 times, doesn't matter. It would take that last submission at midnight, and that would be your submission. For those interested, it was a palindrome program, so you had to detect palindrome strings. I was in the lab, and I thought, well, what can hurt? I can submit something now, and I'll have some result. I had 45 minutes, and I just hacked away. I think I submitted maybe 20, 30 times in that 45 minutes. And by the end, I kept hitting give, and by the end, I had a high distinction in 45 minutes. It was due in 4 weeks, but I had essentially knocked that out of my life. And it was this moment that made me think, geez, moving fast is really, really nice. It's this compounding effect of being able to move quickly to unearth the unknown, to move that unknown to the known unknown, if you will. And I've used this time and time again with every job that I've worked at, and with all of the teams that I've worked with, is that if you can move quickly, you can find product market fit much faster. You can do feature validation. You can do all of these things. And just last week, I was working with another customer, and they're in the US, pretty big company, and they said, we really need this thing. And we went through a bunch of validation, but it was the end of their day. And our team was just waking up in New Zealand, and we had shipped something overnight, essentially, over their night. So they went to bed at 5, they woke up at 9, and there was the thing that had solved their problem. Tell you what, moving fast, amazing at building customer empathy. And this is really what I like to lean on with my team at BuildKite, is if we can move things from the unknown unknowns, the things that we aren't aware of and don't understand, and we can move them into the known unknowns, that is amazing. And the faster we can do that, we can then learn. We'll at least know that there is a problem, and we'll start to build a strategy on how to solve that problem. Eventually, we'll be able to move that into the known knowns, and we'll be able to solve it. And it's this cycle that speed gets you, the ability to move from the unknown unknowns to the known knowns. And I guarantee that if you move fast, your knowledge will compound the same as interest in a bank, money in a bank. If you can ship small incremental changes 10 times a day versus one big change per week, after 28 days, you will be 6 times ahead. You'll have 6 times more knowledge of moving from those unknown unknowns to known knowns. It works exactly the same, and it is phenomenal. Right. This is echoed throughout industry. And love him or hate him, there is a podcast that I love listening to called The Quiet, and Mark Zuckerberg was on it, and he said, if we can learn faster than everybody else, we are going to win. Speed is the competitive advantage. So if the why is speed is the competitive advantage, why doesn't everyone move faster? You know, AI is here. Surely we're moving at breakneck speed with AI. We are super, super productive. What are the challenges with moving fast? And also, can you define fast, please? Because it's all a bit relative. So Kamal was talking about Gumtree's goals of a full regression test in under 10 minutes. And also depends on like how many tests you're running and you know how big the suite is, blah, blah, blah. I have seen massive companies with 5,000 engineers do a full test in under 2 minutes. And we're talking millions of tests. It is mind-blowing. But Horses for courses. Let's break it down. Let's take a look at the challenges of fast relative to the org's maturity. Right. So we break things down in a testing maturity curve at Bill Kite, and we've got on the left axis, the y-axis there, it's the cost per engineer to run tests. Essentially, that's everything, including your compute, your AWS build, your GCP, Azure, whatever. And then on the x-axis, the size of the org or the size of the product. So if you've got more engineers, you're going to be running a lot more builds, or if you've got a big product, you're going to have a lot more tests to cover all of that functionality. And in a startup, you're really caring about product market fit. That is your goal. It is to build something that people love and can't live without. You're trying to, provide value, finding product market fit. You are thinking about testing a little bit, but really, that's not where we're going to focus our time, because where their mind should be at is really making sure that their company survives. So the next area that we look at is the scale up, and that's turning a product that has product market fit into a repeatable, scalable business. They're focusing on process and predictability, performance. And you can see that the cost there starts to go up. After that, we've got growth. They've kind of got the fit. They're really looking at efficiencies. They're going to drive down that cost of the curve. And then we've got a mature organization, probably a public company, and they're really just going to compound their returns and stay ahead. Right, so the first challenge that everyone faces is, I want to make my tests faster. I want to make my build faster. And it's taking whatever the time. It might be days and you're wanting to go to, it might be taking weeks and you want to go to days. It might be days and you want to go to half a day, hours, minutes. Insert your desired goal. The first question I always ask is it parallelized? And if it is, well, we'll talk about test selection later or come to the booth. But if it's not, geez, you should be parallelizing it. If nothing else, move to at least 2 nodes. The first node, in this diagram, you've got a single node running a test suite in serial. It's 36 minutes, might have a bootstrapping time of a minute. And if you go to a second node, that is the best investment you're ever going to get. From there on, you need to double your compute spend to get a similar performance gain. So 2 to 4 nodes, to 8 nodes, to 16, to continually halve your build time. But you should absolutely do it. And this is kind of theoretical. I think everyone goes into this going, oh, this is my node. It takes 36 minutes of wall time, and I need to get this down. So it's going to look like this. I'm going to split it across 10 nodes. It's going to be amazing. 4.5 minutes, that's what it's going to be. And they have big dreams, big aspirations. And then it looks like this. And they go, what went wrong? Why do I have one node that is super hot, taking 15 minutes, and all the rest are under a minute? And they've done the right thing. They've started to split it. I mean, they've already had a gain. They've halved their build time, which is awesome. But how do we get it better? And so what we see, these teams, admittedly, this would be a smaller team. They will start manually rebalancing their test suite by hand. I literally will hear people doing this. Yeah, it's a hot file. I'll just move it into another file. It'll get picked up. It'll be on a cooler shard. That's fine. You can only really do this once or twice. Kind of those edge outliers. Option 2 is they start building some awesome infrastructure, and by awesome they really start building some cool gear. I mean, you can really bike shed this. They've got their environment, they've got their outputting Jane and XML, and they're ingesting that into some data store, all that timing history, all of that time series data that, that gentleman in Sydney 3 months ago was like, what's the point of that? And then they build a dispatcher as well, and they orchestrate it all. And the problem with this is, it's great fun, and it will improve and get a much more better distribution of your tests across nodes. But you're now having to maintain 3 or 4 different pieces of infrastructure, and they're all critical. If any one of those go down, your CI is broken. On top of that, you've got JUnit. Maybe your testing suite will output to JUnit XML. Maybe it's JSON. So now you've got a bunch of different parsers for different test suites. And this is totally a suitable method. And we see teams do this all the time. It's absolutely fantastic. But when they realize that they've got more time, they want to spend time doing things that are going to make their own product better, they typically come to BuildKite, and it's about 3 lines. And they go, I'd like the parallelism, please. I'd like you to bin pack it, and we'll bin pack it for them. And so that is bin packing, and it's the first thing that we see all of the teams that we work with do on their journey towards breakneck speed. So the next challenge is reliability. And flaky tests are horrible. Obviously, they're the bane of every engineer's existence. Maybe not the absolute worst thing, but they're pretty bad. But they are localized pain. So, if it's just one engineer and you're running it on CI and you get a flaky, well, you can take some medicine for your localized pain. You can pop an Advil, a paracetamol, ibuprofen. You can kind of mask it. And I think you all know that that's hitting the retry button. You hit retry, it goes green, and you're like, yeah, cool, I'll ship that. And that's totally fine. Kind of works to an extent. But then your team wants a merge queue. Can I get hands up for how many people are running merge queues? 4 or 5, so a handful of you. I'll just do a quick, brief intro on merge queues. There are only, it's not going to be a surprise to you, but there are only so many hours in a workday. And if you've got a build that takes 10 minutes to run, you essentially have only 48 slots that you can deploy. So if you have higher concurrency than that, then you essentially will need to be looking at a merge queue to maintain that throughput. Now, the problem with a merge queue, they solve a lot of problems, but they introduce a bunch more complexity, is that if you have a flaky in a merge queue and you have 5,000 engineers, or even if you have 50 engineers, doesn't really matter, you have one flake in that merge queue, then you have 49 other engineers, or 4,999 other engineers now going, why can't I deploy to production? How do I solve this? And we've seen teams combat flakes on merge queues with a number of different strategies. The retry strategy is pretty common. We see typically they start with good intentions of, let's just do one retry. Then they get to, it won't hurt if we just bump it. Let's just bump it again. Yeah, no, it's okay. We'll just keep bumping. And literally, I've worked with teams that have strategies of 10 retries per test. 10 retries, and we're like, come on. There is a better way, but we're guiding them to that. Probably my favorite retry strategy is the preemptive retry strategy. Now, this is if you've got lots of money and you want to burn it really quickly, but you want to move fast. It is fantastic because what you can do is you can run all of your tests concurrently, like the same test 3 times, expecting that one is going to fail. And at least you don't have to wait for the retry because you're doing the retry preemptively. And I kind of think of this as like, someone in a casino with 15 roulette wheels around them, and they're just like placing all these bets all in one go just so that they can fail faster. But they will win faster as well. So the preemptive retry strategy, definitely very, very good if you want to go fast and have deep pockets. And this is where we see that curve in the scale-up part, They care about shipping the product as fast as possible. And the cost there is probably going from $1,000 per engineer per year in CI to maybe $4,000. So the cost isn't that significant. It's much, much more important for them to continue shipping. So retrying, totally valid. But is there a better way? So the high-performing teams that we work with, they treat a broken merge queue as an incident. It is probably not P0, but it's definitely up there. It's probably P1 incident, and they will down tools and fix it. They have a zero-tolerance policy towards flakes. So they will build a flaky management workflow. And that includes using identification heuristics, quarantining, muting. They map every test to every team so that they can drive accountability. They have timeframes. Fix it, or it's going to be deleted in 2 weeks or a week. And they will only reintroduce a test once it has gone healthy again. They're not going to say, bank on the word of an engineer who said they fixed it. And we see them using agentic LLMs now on remediating their tests. So in BuildKite, this kind of looks like this. We have workflows. They can set thresholds. They monitor a set number of tests or a very specific sub-selection of tests. Maybe it's the reliability on ARM versus x86. Maybe it's different database versions, whatever it is. They'll then set all of the steps, that maps to their policy, what will happen when it alarms. Is it muted? How's it labeled? Who gets notified? What are the steps forward? And once it's resolved, essentially it's the inverse of that. So when it comes to flaky identification, they will pick a number of heuristics that work for them. Usually flaky heuristics all have pros and cons depending on what you're looking for. But a really, really common one, if you're after a heuristic, is a state transition or a transition counting heuristic. And that is essentially where you can see at the top, every test is green. This is like on a main branch or a merge queue. So it has a very low score of 0. Once it starts flip-flopping, it will have a high score, 0.6 there. It's done 6 transitions out of 10. But when it is good and then it starts failing, it's consistently, deterministically failing, it's back to a low score. So it's quite a good, easy to wrap your head around model for detecting flakes. And this is all built into Test Engine. So you don't pick this one, pick one of the other ones. There are a number to choose from. And of course, you could build this yourself if you were so inclined to go through the torment of doing it. Once you've got these, you want to keep your teams accountable until that test is resolved. And by resolved, I mean either it is healthy again or it is deleted. If you have a flaky test, it is not providing any value to your org. Might be providing some value depending on your retry strategy, but and depending on your product. But for the most part, you really need to take care of them, particularly if you've got a merge queue. So make sure that your teams are being notified and tell them clearly what's going to happen with that test. And I think a really good strategy here is don't just go to the engineers, but go to the people who are held accountable with these tests. So if you've got product managers who care about the product being functioning, get them looped in on these notifications, because I can guarantee you a product manager does bear a lot of risk when their product stops working. Engineers, of course, need to be able to go back in and they need to track the reliability of that test. They need to know what caused it to go flaky and when it's healthy again. What's the time? Where am I at? About 20 minutes. This is kind of the latest thing that we're seeing with the teams that we're working with, is they're taking all of that data, all of that time series data, all of the execution data, and then they're pumping that into an LLM. And that is using Test Engine. They can reduce the context, so you're not smashing 100,000 tokens into an LLM. You're just getting the right context for the LLM to then solve the flaky. And this is amazing at taking all of the grunt work out of resolving flakies. It does a remarkably good job at detecting whether this is a race condition flaky or if it's a type coercion flaky. They're very, very good. So with flaky management workflows, the team is aligned on delivery speed being an advantage, being a strategic advantage. It's going to keep that critical path clear. So if you've got a merge queue or if you're thinking about a merge queue, you absolutely need to have a flaky management strategy. You're going to have happy and productive engineers, and you're going to have less dollars spent on wasted compute. All right, let's take a quick look at growth. I know I'm going to be running out of time soon. Right, so the next thing we see is how can I run my tests fast, but not spend all of the money on parallelism that you mentioned before. And this is kind of like almost the pinnacle in when you're getting to optimizing your test suites. So test selection is really just about how can we identify a subset of the tests that we need to run, but still have the full confidence of the result of the test suite. So it's a pretty simple example here, but this is just a change to an email, some text, maybe it's like a mailing list or something like that, or a sign-up flow. And without test selection, you're going to run 20,000 tests in this test suite. It's going to run everything, and you're going to burn a whole heap of compute. You could just run the ones that are relating to that, the email. So 200 tests there that you're going to run. You're going to spend 1% or 10% of the compute that you were before. And the most common strategy that we see today at the teams that we work with is building a dependency graph between the test and the application code. And they might do this using static analysis, dynamic analysis. Whatever they do, they build a pretty large graph mapping that. And they have to keep that graph up to date. So ideally, it's on like a nightly build. They will continually build this graph. And it is pretty impressive what you can do with test selection. The pros, you're going to have teams really reducing that CI spend. Could be up to 50% or more on feature branches. Obviously, on your main branch or a merge queue, you're probably going to run your full suite. But when an engineer is working on a subset or a feature, you can get away with running significantly less. So a massive reduction in time to delivery because the engineers just don't have to wait that full time. But boy, they are complicated to maintain. You really are ramping up your infrastructure complexity, and again, it becomes part of the critical loop. You're maintaining something that is not part of your product, but underlying it. Not only that, but we also see teams that if you're not running your full suite, you might be running just a sub-selection, but engineers find it quite difficult to immediately reason, is this test that I've just added, is that being run? Has it been selected correctly? Or this change, should it have run all of them? So it's a cognitive load increase in not just the infrastructure, but also in the engineering team as well. But definitely something to look at once you've done everything else in optimization. So that's kind of where we're at with the key three or four things here. In the early stages, you're looking at parallelization, you're looking at merge queues, you've got to make sure you've got a flaky management strategy. You're looking at agentic AI remediation. Once you've got to that peak, you're going to look at cost reduction. So you're going to start looking at test selection. You'll probably start looking at spot instance and fleet management, so how you can identify what spot instances are more reliable than others, and how you can then manage block lists and allow lists based on their reliability. And then once you're into the very, very top end, you're looking at all of that, but without the complexity. How can you reduce all of this? Okay. So, time to land this plane. So why is the speed? The why is the speed as a competitive advantage, and this is the how. And I'm going to leave you with one of the teams that we work closely with, which is Rippling. They have a massive test suite. They're really, really, really high throughput. I can't put down specific numbers here, but rest assured it's big, and scan the link. You'll hear all about it from them. They're doing everything. Bin packing, flaky management, auto quarantine. They really rely heavily on AWS's spot instances. They will essentially do arbitrage on spot instances, and they will find the best place to run their tests around the world. They use test selection to reduce the number of tests, and they are seeing amazing gains, 90% plus in the reduction of their compute, but they still have blistering speeds to production. And they aren't a household name, but wow, the engineering team is incredibly talented. All right, so that's a big thank you from me. I was told to make sure I left time for questions at the end. Come chat with me at the Bill Kite booth, grab some swag, and I think we're doing a question as well. Is that right? Do I ask the question now?
Yeah.
Oh.
Thank you so much. It was good to know about all the testing curve and the different stages over there. This is Q&A time. Any question for James?
Yes.
Does Fieldkite offer any inbuilt capability to skip the pipeline jobs? I mean, voluntarily, because I'm having 10 jobs, for example, and I don't want to test all the 10 jobs. I'm interested in only one job for that particular PR. So is there any inbuilt capability to skip the rest of the jobs and just execute only that one?
Yes, so was the question, was it about retrying and not retrying all the jobs? Or just selectively running?
The job, yeah.
Yeah. Yeah, definitely. So Bill Kite has a number of products, but the pipelines product that we have, it's not my product, but I can talk a little bit to it. They have the ability to dynamically select what you want to run specific to the stuff that's running. So it's very, very powerful. Come by the booth and we can chat more about it. Yeah.
Let's just say you have an environment that's terrible, okay? So the tests fall over at any point, but it's not actually the test itself, right? I loved the concept of being able to go, okay, I'm going to disable this test. Did you have rules where it was kind of like, actually everything's just failed at this point, so we're not going to quarantine
100%.
all the tests, yeah?
Yeah, definitely. So we see lots of teams essentially, anything that you might have end-to-end tests that have a number of network dependencies or something like that, and as soon as that's going out, all of it's going out. So you definitely want to set a threshold that if the majority of the tests that are failing within that run, then you're not going to do that as well. So 100%, yeah. Yeah.
Any other question? Nope. Okay. Time for a sleep check. So after lunch, we call this as a sleep check. Now, James is going to ask a question, and for a sleep check, he's going to give $50 to one who's going to answer. So over to you, James.
All right, so the question is, list 3 things high-performing teams are doing to deliver at scale. That's 3. Winner, winner!
Thank you so much. Once again, give a huge round of applause to James.
you.